welcome back to the second half of the first iris2 tutorial video. As you can see, the inversion has successfully finished. It took less time than the time predicted by the code. That's good. And it saved a file that, as you can see here, has a name very similar to the input file. The only difference is that the code has changed iris underscore level 2 for iris2 model. In addition, we have the output of this function. Let's see what is in the output. Okay, as I mentioned in the first video, the output is a structure. The structure has several variables, and as I mentioned, we are using the highest information level available in iris2, and that's why I have so many variables. First, I have the file name of the data that has been inverted. As you can see, this is the location and the file name of the data the data set we used. Then you have the file name of the files in the iris2 database. As you can see, by default, iris2 is using the latest available iris2 database. However, you can change that and use previous versions. Then you have some information relevant about the inversion, for example, the optical depth, the wavelength sampled during the observation, the mask that we use to mask the data, avoiding bad pixels or pixels with a value. You have other values about the inversions. So for example, here is the number of pixels that we have inverted and the number of representative profiles that we have used from the iris2 database. And here you have the model. This is the model atmosphere recovered by iris2. As you can see, it has X dimension, Y dimension of the observation. This dimension is the optical depth of the atmosphere, and this is the variables, physical variables in the atmosphere. All this information is given in this variable as well. And here we are giving the name of these variables. In this case is temperature, line of sight velocity, microturbulence, and electron density. In addition to the model atmosphere, you have the uncertainty for each of the variables in the model atmosphere. As you can see, dimensions are exactly the same that the ones in the model. The description of the uncertainty dimensions and uncertainty variables are given in these two variables. Again, because we are using the highest information level available in iris2, we are having the highest return from iris2. That includes iris calibrated data. This is the original dimension of the calibrated data and the observed wavelength in the calibration data, in the calibrated data. In addition, you have the inverted data. This is the representative profiles found by iris2 that match in the best way to the original data. Then you have the chi-square map. As you know, chi-square is used to quantify how well the match between the data and the inverted data, in this case the representative profiles in the iris2 database, is. Then you have these two maps. This map is giving us information about the index in the database of the representative profile found by iris2 that is the best match of the observed profiles. Here, this map is telling us where the representative profile in the database is located. As you know, we are using representative profiles from different observations at different locations in the solar disk at different mu values. Therefore, each representative profile has associated a mu value. All these values are given in this map. We have as well the header of the original data, the mu value of the observation that we are inverting, and this delta mu is a value around the observed data that you are using to look for the data for the representative profiles in the database. In this case, we have not constrained at all this range around the observed mu, and then is considering all the values in the database. As you can see, the delta, the increment is 1. Therefore, this is going to be between 0 and 0.8 plus 1. Of course, this value, mu, is only valid between 0 and 1. Therefore, it's considering all the data in the database. In Factor, you have the information used to calibrate the data from the original data numbers to the flags in CGS units. And here you have some information about the performance of the inversion. Because we have inverted only one file, iris2 model is just a structure. As I mentioned in the previous video, if we invert a collection of files, this will be an array of structures like this one. Well, in iris2 model structure, we have all the information we need to investigate the model atmosphere and how this model atmosphere was recovered. To that aim, we have developed and brought an inspector tool to analyze the iris2 model. In the following videos, you will learn how to use this tool. See you then.